Welcome back, students. So what we had been discussing by now is how top-down parser is going to behave. For top-down parser to execute, it is going to consume two things, a stack and a predictive parsing table. So we have already discussed how predictive parsing table can be created. Now what we are going to discuss is top-down parsing algorithm. So suppose we have an expression id plus id multiplied by id, and we need to validate whether this grammar is syntactically correct or not applying top-down parser. Then how we are going to do that? Let us start from the scratch. Means we are going to follow the entire procedure. So for following entire procedure, we need to first of all consume our grammar, create the parsing table, use the stack and parse it. So let me first of all rewrite the non-left recursive predictive parsing rules for this, as it contains left recursion. I won't explain how, we should already know now. E derives t e dash derives plus t e dash or epsilon. T derives f t dash derives star f t dash or epsilon. F derives bracketed e or id. So this is the rules we are going to consume for creating predictive parsing table. Let me write the first and follow values also derived from this particular non-left recursive grammar only. So if you consider first of capital E, it is going to be first of T is going to be first of F is going to be opening bracket and ID. See, we have already discussed this, so I am not going to give any kind of explanation for this. You have to assume first of capital T is going to be first of F, and first of F is opening bracket and ID. Okay. First of F is again opening bracket and ID. Okay. First of E dash. First of E dash is plus and epsilon. First of T dash is star and epsilon. Okay, fine. Moving ahead. So we have calculated E dash, T, D dash and F. Now we are calculating follow values. So follow of capital E is by default dollar. Then because of this rule, it is a closing bracket as well. Follow of E dash is two rules. This is recursive, so we'll consider this only. Follow of E dash is follow of E, hence dollar and closing bracket. I am not writing the entire description or justification. We have already calculated once these examples. Follow of T is, so there are two examples where we have T, after which we have E dash. So follow of T is first of E dash. What is first of E dash? Plus and epsilon. Plus epsilon. If you replace E dash by epsilon in both examples, after T you have nothing. So follow of T is going to be follow of E. So the value I have is dollar and closing bracket. Okay. Follow of T dash is going to be. So if you observe both the rules, after T dash you have nothing. In the second rule it is a recursive call. Follow of T dash is follow of T dash. So I will consider this. Follow of T dash is follow of T. So it is plus dollar and closing bracket. Okay. Now follow of F. Okay. So what is follow of F? If you observe, F happens to be over here and over here, two positions, after which you have T dash. So that is first of T dash. What is first of T dash? It is star and epsilon. If you consider epsilon, then replace T dash by epsilon. So after F you have nothing. In this case, follow of F is going to be follow of T. Follow of F is going to be follow of T dash. Both is same. So follow of T, that is star plus dollar and closing bracket, is going to be the answer. Right? Okay. So we are quickly going to design the predictive parsing table as well. So if I design predictive parsing table, I am going to have how many rows I am going to have? I will have E dash, T dash, F. Okay. How many columns I am going to have over here? So I have plus. Okay. I have multiplication. Fine. Then I have opening bracket. Okay. I have closing bracket. Okay. And then I have ID. And the last thing which I am going to add is dollar. I'm extremely sorry. Okay, so this is how I have created table. I'm going to quickly place the values over here. For making the value in the row of E, I will observe follow of E, that is opening bracket and ID. So opening bracket and ID. So there are two, let me number the rules. This is R1, R2, R3, R4, R5, R6, R7, R8. Okay, fine. So for making the entry in the row of E, I have to observe what is first of E, opening bracket and ID. How many rules are derivable from E? Only one, R1. So R1 will be written here also, R1 will be written here also. First of E dash. First of E dash contains plus and epsilon, so I will select plus. As it is epsilon, I will go to follow of E dash, that is dollar and closing bracket. So I will select dollar also and closing bracket also. So how many rules are derivable by E dash? R2, R3. R2 starts with plus, so it is going to be written here. R3 is epsilon, because of which two columns have been selected. So R3 is going to be written here and R3 is going to be written here as well. First of T, it is closing bracket and ID. So T is deriving how many rules? Only one, R4. So R4 is here, R4 is here. First of T dash, star and epsilon. So star is selected. As it is epsilon, I have to observe follow of T dash, that is plus, dollar and closing bracket. So plus, dollar and closing bracket. How many rules are derivable from T dash? It is R5 and R6. R5 starts with star, so R5 will be here, and R6 is epsilon, because of which three columns have been selected. So R6 will be written here, here and here as well. Finally F. So what is first of F? Opening bracket and ID. So opening bracket and ID. How many rules are there? 2. The R7 starts with opening bracket, I will write here. R8 starts with ID, so I will write it over here. See, it's so simple. Now this is halfway done. Now we are going to discuss the predictive parsing algorithm actually. So how to solve this expression, whether it is syntactically correct or not. So let us imagine we have readily available stack. So in this stack, the expression I am going to add is this. So we are going to have 3 columns. Okay, fine. So this is the expression. Okay, this is always going to be ended by dollar. Dollar should be appended at last always. Then the actions which we are going to have over here, that we are going to write. Okay, and this is our stack, which will have dollar by default, empty of the and bottom of the stack is going to be indicated by dollar. So what we have over here, this is our stack, this is our how algorithm is going to be applied. So we are going to use the stack, we are going to use the parsing table. This is the expression, how it is going to be evaluated, and these are the actions which we are applying, the rules which we are going to apply, we are going to write over here. So initially, what is the initial condition? The expression is always going to be terminated by dollar, and the bottom of the stack is also going to be indicated by dollar. Okay, now this is a top-down parser. How top-down parser works? In top-down parser, if I want to prove that ID plus ID multiplied by ID is correct, how I am going to do? I will start from E and I will try to reach to expression. That is called top-down approach, right? So what is the start symbol or starting step of a top-down parser? The start symbol of the grammar. So by default, initially capital E is going to be pushed onto the stack. The expression remains same, ID plus ID multiplied with ID dollar, and there is no action we are going to specify over here. Now what is next? Now here the algorithm works, so listen carefully. What do you have to do? Repetitively observe what is top of the stack, capital E. What is the current input symbol? This is your input expression. This is your first current input symbol ID. So observe your top of the stack always and the current input symbol. What is your top of the stack? That row you have to check. And what is your current input symbol? That column you have to check. So it is EID. What is the value for EID? It is R1. Okay. So which rule we are going to apply? R1. What is R1 rule? R1 says E should be replaced by TE dash. Okay. Are you getting? Let me repeat. Top of the stack is capital E and current input symbol is ID. So from the table we need to get the value of EID. EID indicates R1. What is R1? E derives to E dash. So from the stack E should be popped and TE dash should be pushed. What is meaning of E derives to E dash? E should be replaced by TE dash. If I will be pushing TE dash in the stack, when I pop back, what I will get? E dash T, which is wrong actually, because we are interested in replacing capital E by TE dash. So when we pop back, we should get exactly TE dash, not the reverse. So what we have to do? We have to push in reverse. Simple. So what is the right hand side of the rule? TE dash will reverse it. So what it will become? E dash T, that we are going to push over here. Simple. The expression is same here. ID multiplied by ID dollar. Once again, what is top of the stack? Capital T. What is current input symbol? ID. So T and ID, it is R4. What is R4? T derives FT dash. Means T should be popped. E dash will remain as it is, but T will be popped. Now instead of T, what should be written? FT dash. But in reverse. So T dash F. The expression will remain still as it is, followed by dollar. So R4 is applied over here. Now what is current top of the stack? F. What is current input symbol? ID. So we'll observe F and ID, that is R8. So what is R8? R8 is F derives ID, means F should be popped, ID should be pushed. R8. So E dash in the stack, E dash and T dash will be as it is. F will be popped and ID will be pushed. Now don't push it like DI. ID is an atomic symbol. ID is an atomic symbol. So it won't be reversed. It will remain ID only. Okay. The expression is ID plus ID multiplied with ID dollar. Now what is top of the stack and what is current input symbol? Both are same. So a match is found. When a match is found, what you need to do? The pop operation. One pop operation will be performed and the expression will be incrementing current input symbol by 1. So next symbol is going to be current input symbol. I repeat, when a match is found, what you have to do? Then the top of the stack symbol will be popped and in the expression the current input pointer will be incremented by 1 because this is validated. This up to this expression is valid. So my stack will contain E dash, T dash only and ID is validated. So I will remove it. I have plus ID multiplied with ID and dollar in my expression. What is top of the stack? T dash. What is current input symbol? Plus. So T dash and plus, that is R6. R6. What is R6? R6 says epsilon. So what I need to do? T dash derives epsilon, means E dash will remain as it is, T dash will be popped, epsilon should be pushed. What is meaning of pushing epsilon? Doing nothing. My expression remains same, plus ID multiplied with ID dollar. What is current top of the stack symbol? E dash. What is the current input symbol? Plus. So E dash and plus R2. What is R2? E dash derives plus to E dash. So I am going to pop E dash and plus T E dash in reverse need to be pushed. So it will be E dash T plus. The expression is plus ID multiplied with ID dollar. The top of the stack and the current input symbol is declaring a match. So a pop will be performed and input pointer is going to be incremented by 1. So what is the stack content we are going to have? The stack contents are dollar, E dash and T. And the current input symbol contains ID multiplied by ID dollar. Now what is top of the stack? T. What is current input symbol? ID. So T and ID, it is R4. What is R4? R4 says T should be popped and FT dash should be pushed. So E dash will remain as it is, T will be popped and T dash F is going to be pushed. ID multiplied by ID dollar as it is. What is top of the stack? F. What is current input symbol? ID. F, ID, R8. What is R8? F should be popped, ID should be pushed. So E dash and T dash will remain as it is and F will be popped, ID will be pushed. ID multiplied by ID dollar will remain as it is. Okay. Now ID is the current top of the stack and ID is the current input symbol. So a match is declared. When we have a match, what we need to do? A pop should be performed and input symbol should be incremented by 1. So this is going to be our case now. ID is validated. Now T dash and multiplication. So if you observe T dash and multiplication, the rule is R5. What is R5? R5 says T dash should be popped and star FT dash in reverse should be pushed. So I will pop T dash and instead I will be pushing T dash, F and asterisk. Current input expression will be as it is. So top of the stack and current input symbol, they are declaring a match. So one pop will be performed and the input symbol will be incremented by 1. So the next current input symbol is pointing to ID. What is top of the stack? F. What is current input symbol? ID. So F ID. That is R8. What is R8? F should be popped, ID should be pushed. So E dash, T dash will remain as it is. F is popped, ID is pushed. ID dollar. Now top of the stack and current input symbol, they are declaring a match. And hence this pop will be performed and current input symbol will be incremented by 1. So we have only dollar here. Now T dash dollar. So if you observe T dash and dollar, it is R6. So what is R6? R6 says T dash should be popped, epsilon should be pushed. Means nothing. E dash, T dash is pushed and nothing is, T dash is popped and nothing is pushed. Nothing means epsilon. Now E dash and dollar. If you observe E dash and dollar, it is R3. What is R3? R3 again says epsilon. Means E dash derives epsilon. Okay. So what you have to do? E dash is popped and nothing is going to be pushed. Okay. So dollar, dollar. You have nothing over here. So this is declared as success. What is the meaning? The expression ID plus ID multiplied by ID is syntactically correct as per this grammar and as per the predictive parsing table we have created. So whenever there is a question like for the given expression, check whether apply top-down parser or apply LL1 parser, they won't be asking you to perform the entire process because this cost 14 marks. For this 7 marks and for this 7 marks. So what they'll do, they'll give you this table readily available. So what you have to simply do is read up the value from the table and apply the algorithm. But mostly in the GTU papers, they are asking this portion only, yet we should be very clear with the parsing algorithm also. So I hope you have understood how top-down parsing algorithm, LL1 parsing algorithm is working. So if more examples have been given to you where you have to apply the parsing algorithm, you should be very clear how to apply the parsing algorithm here. So we won't be solving more examples for applying the parsing, or let us say we will be solving one more example where we will be taking a parsing table which want to be a desk calculator parsing table readily available, apply the parsing algorithm and check the string whether it is syntactically correct or not, and we will also check for the syntactically wrong expression, hence we can validate it. So we'll be doing that in next coming lecture. After that we'll be discussing about another top-down parser that we have to discuss, which involves certain diagrams, and after that we'll start with bottom-up parser. So that's all about this lecture. Keep watching the videos, and whatever assignments are going to be uploaded, please do assignments and do proper practice for this example, as 7 marks compulsory question is going to be asked from this particular portion itself. Not just this, you should be clear with the parsing algorithm as well. One more example we'll be solving in next coming lecture. Thank you for watching. Stay happy and healthy. Thank you.